Hey everyone, Mr. Voikin here, and we're going to continue on with Unit 3, Lesson 4, 5, 6. So, doing unit conversions, and we're going to take a look at what we call proportional reasoning. So, proportional reasoning is basically making two equal ratios, so two equal fractions. So, this fraction equals that fraction. So, whatever is up on top, A, would have to be on the top on the other fraction, and whatever units B are on the other one on the bottom need to be on the bottom of the other one. So we use this quite often in just basically trying to solve a number and convert a fraction, reduce a fraction, so make an equivalent fraction. So if I say to you that I have 4 over 5, that equals what over 20? So basically we can see that 5 times 4 equals 20. So whatever I do there, I have to do to the top, and we should end up with a 16 right here. But if the numbers were decimals or a little bit harder to visualize that, we use what we call cross multiplication. So it's like 5 times x, that equals 5x. And then 4 times 20, and that equals 80. So we now have a standard algebraic equation right here, 5x equals 80, and now I need to isolate the x, and to do that I move the 5 over to the other side by dividing both sides by 5. That cancels the 5's on this side, and I'm left with x equals 16. Okay? All right, so I can use proportional reasoning to convert between units if it's just one stage. So if I know that one unit has a certain value in another unit, I can then set up equivalent ratios and use cross multiplication right there. So let's just say that I know that 1 mile is equivalent to 5,280 feet. And then I say to you, well, how many feet would be in 6 miles? So basically I'm setting up an equivalent fraction that says 6 miles is how many feet. And now I have a very similar setup to what we had right here, and all I'm going to do is cross multiply. So I'm going to go 1 times x, which is just x, and that equals 6 times 5,280. So 6 times 5,280, and that's as simple as punching into the calculator, and we end up with x equals 31,680, and in this case where the x is associated with the units feet, so we need to include those units right there. Okay, I'll do one more with the unit conversion. So for example, I know that 1 yard is equal to 0.9144 meters. Now, if I tell you that I have 450 meters, and how many yards is that? Again, I just need to set it up in the same way with the yards on top, okay? And that's because we're making it equal here, right? So, and the meters on the bottom. And again, I now have two equivalent fractions as long as I make the ratio on this side equal to the ratio that's on this side. And to do that again, all we have to do is cross multiply. So I get x times 0.9144. So I get 0.9144x equals 1 times 450, which is 450. Now I need to isolate the x by dividing by, running out of space, 0.9144, and doing the same on the other side, and that will cause these to cancel out, leaving me with x equals, and again, just grab your calculator, and 450 divided by 0.9144 gives us 492.1259 and a whole bunch of other numbers, and we would round that to wherever the question indicates to round that number off to. Okay, now proportional reasoning is also when we're comparing other things, like this is quite common where it takes 43 minutes to travel 75 kilometers. How many minutes will it take to travel 270 kilometers? Well, all we have to do is just, again, create something that is equal on the left side and the right side. And so I'm going to take a look at first that we're talking about it takes 43 minutes to go 75 kilometers. So it doesn't matter where I put the minutes and the kilometers. I could put 43 minutes up top right here and the kilometers on the bottom, or vice versa. So since it's written minutes and then kilometers, I'll just take it in that order. So I got 43 minutes up top and 75 kilometers. That means that whatever's on the other side, in order to make it equal, I'm going to have minutes up top and kilometers on the bottom. And what do they tell us in the question? Well, how many minutes? So how many minutes, when we're saying how many, that is going to be the x, and x is with the minutes. And now it tells us to go 270 kilometers, so my 270 is going to go on the bottom, and we're going to cross multiply. So 75 times x is 75x equals, and now I've got 43 times 270, so 43 times 270 is equal to 11,610. I need to isolate that x by dividing both sides by 75. That will cancel the 75s, and I'm left with 154.8. And because the units associated with the x are minutes, then my answer must express those same units. Okay, I'll move on to question number 2. Okay, so in this case, it's saying that it costs 4,750 mop to purchase 9 pairs of shoes. How much would it cost for 58 pairs of shoes? Again, using proportional reasoning, what do I know? Something on the right has to equal something on the left. So what do I start with? I'm starting with 4,750 mop. And what does that get me? It gets me 9 shoes. And it tells me I want to get 58 pairs of shoes. So because shoes on the left is on the bottom, needs to be on the left on the right, because we're saying that these are equal. And now it's basically saying to me, how much will that cost? So x mops. Again, we cross multiply. 9 times x is 9x. 4,750 times 58 is going to equal 275,500. To isolate x, we're going to divide by 9, cancel the 9s on the left, and on our calculator we just divide that answer by 9, and we're going to get that x is equal to 30,611.11 mops. Okay, now it just basically follows the same type of scenario every single time. So we know we're doing proportional reasoning. Equals, line. On a map, 4 centimeters is equal to 550 kilometers. If the distance between the two cities on the map is 2.4 centimeters, how many kilometers is it going to be? Cross multiply. 4x equals 550 times 2.4. which equals 1,320. Divide by 4. Divide by 4. That will isolate the x by canceling everything on the two 4's on the left side. Because remember, 4 divided by 4 is 1. So basically, what we're saying is the value of 1x is what I want is going to be 1320 divided by 4. So the answer is 330. And what are my units? Kilometers, km. All right, and the last question, I believe, in this section, then we move on to unit analysis, is going to be this one right here, proportional reasoning. So equals, line. A student wants 80% on a test. Now, we all know that 80% is not really a number that we use in any calculation. So how do I represent 80% as a fraction? Well, it can be 8 over 10 or 80 over 100. So now this is the total on the bottom, right? That's what it's out of. So if you get 80%, you get 80 questions right out of a total of 100. That would give you 80%. Now the student wants 80%, so they want something that is equal to this. But how many questions are on the test? Not 100. It says right here there are 43 questions on the test. So what do? We put the total that it's out of. It's out of 43 on the bottom. So how many questions does a student need to get right to equal 80%? So again, what do? We cross multiply. X times 100 is 100x. 80 times 43 is going to be 3,440. Divide by 100 to isolate the x, and we end up with 34.4. Now this is how many questions they need to get right. Now you can't get 0.4 of a question right. So if this was a question on a math test and they have selection A, which is 34, and selection B, which is 35, the correct answer is 35. So if you got 34 right, you'd almost be at 80%, but you're not quite there. So 35 is obviously a little bit more than 80%, but you need at least 35 questions right to get that answer correct. And quite often, again, if they tell you to write it out in sentence on the test, the student needs to get 35 correct answers. Okay, so hopefully this will help you get more than 80% on the test that we have for this unit. And if there's any problems you're still having, come and see me. The next video, we're going to take a look at unit analysis.